We'll start by looking at a few absolute value inequalities and determine whether or not it's true for the given value. The absolute value of x is less than 2. What that means is the absolute value of 0 less than 2? Well, the absolute value of 0 is just 0, and that is indeed less than 2. The next thing we'll look at is the absolute value of negative 3. Remember, the absolute value of negative 3 is simply 3. Is that less than 2? It is not. Similarly, if we take the absolute value of 3, is that less than 2? It is not. We can do the same thing when we're multiplying, dividing, adding, and subtracting. Well, 0 minus 1 is negative 1. The absolute value of negative 1 is simply 1. Is 1 greater than 8? Eight minus 1 is 7. Is 7 greater than 8? Negative 8 minus 1 is 9. Is 9 greater than 8? I'll let you take a look at the next two. You can pause here and determine which values is true for. What you need to understand about absolute value is that it actually represents a distance between some value and the origin, or 0, on a number line. So if I'm taking the absolute value of negative 5, the reason I say that that's equal to 5 is because there is a distance of 5 units between the value I'm looking at and 0. That's why the absolute value of positive 5 and the absolute value of negative 5 are the same. Think about a distance like driving from your house to school and from your school back. We don't call either one of those distances negative. They're just distances. When we start to solve absolute value equations and inequalities, we'll start looking at conjunctions and disjunctions. If we have an equal sign, then we know that the value within there is equal to one number or the other number, which means the distance between the number in this absolute value and 0 is exactly equal to that value. When you start looking at the inequalities, if you have a greater than, it's an or, which means that the distance between some number and 0 is greater than whatever your value is. In this case, it's 1. If you have a less than, it's going to be and. That means that the distance is going to be less than 1 in both of those cases. So in order to solve these, you have to write either the conjunction or disjunction. That means you're going to have to memorize greater is or, less is and. You might want to think about it like if it's great or, it's or. Let's take a look at a few. This first one isn't too difficult. We're going to say that 2s plus 3 will be equal to 5, or 2s plus 3 will be equal to negative 5. And we'll solve both of these the same way. So 2s is equal to 2, s is equal to 1. If I solve the other one, I get that 2s is equal to negative 8, s is equal to negative 4. What that means is that my value of s is equal to either -4 or 2. Closed circle because it's equal, and I don't shade anywhere on this number line because these are the only two values that will make it true. The next is my inequality. This is a less than, so it's got to be and. The way that I will set this up is I will say -2 is less than 3 minus k. Then I will say 3 minus k is less than +2. For this one, so that I don't have to deal with multiplying and dividing negatives, I'll add k to both sides, and then add 2. On this, I will do the same thing. I'll add k to both sides, and I will subtract 2 from both sides. I might rewrite this as k is greater than 1. Sometimes you're going to be asked for interval notation. So what this is saying is that k is in between 1 and 5. It's not equal to, so you can write this in interval notation like this. That tells us to use values from 1 to 5. Don't include the 1, don't include the 5. If I graph this on a number line, I would put this curved bracket here and here and fill in. That curved bracket is the same as an open circle. I'm going to change this problem here so that it says this, because now I can look at this as this absolute value with the x in it is greater, or, right, I remember that, and I might rewrite it. 2 plus 1/2 x is greater than or equal to 3/2, or -3/2 is greater than or equal to 2 plus 1/2 x. And I'm sorry, this one isn't written very well. Let's see if I can erase it. Nope. That's 1/2 x. So when I solve each one of these, subtract 2 from both sides, this gives me -1/2. Multiply by 2 on both sides, and I get -1. Do the same thing here. Subtract 2 from both sides. This gives me -7/2. Multiply by 2. To write this in interval notation, we think about the fact that x is greater than or equal to -1. So that means it goes from -1 to infinity, and because we include the -1, we put this bracket, and then the curved bracket on infinity. Because x is less than or equal to -7, we would say that we go from -infinity to -7. And we would take the union of these two, because we need everything in this set and everything in this set. To graph them, because we're including these values, we would have that closed circle, or you can put these brackets like this, and then you would shade.